Hi everyone, welcome back. Thank you for joining me again. So in this video, I'm going to show you what is a slope field, how to draw them, and how to determine the differential equation from a given slope field. So if you recall from calculus, we know the first derivative represents the slope. So here we're going to be working with first order differential equations so we can draw the slope field in the xy plane. So let's take a look at the first example I have here for you. So here I have a slope field of one particular differential equation. So we want to figure out among these four options, which given differential equation represents this slope field. So how do we do this? Well, we're going to test a couple of points and determine which one makes sense. So for example, if you just look at all of these options, so we have 1, 2, 3, 4. If you look at all of these options, let's take on some of the slope that we're familiar with. So we're familiar with the zero slope. So let's just call it the first derivative, dy dx is equal to slope. We indicate it as using letter m. And we want to know when is this slope equal to 0. So let's use that as one component of this. So among all of these four, when will we have slope equal to 0? So remember, 0 slope is just a horizontal line. So we're looking for when do we have a tiny horizontal line? For example, equation 1, well, if x and y are, so if I do x minus y, then we get 0. Okay, now what about the second one? It looks like it will never be 0. Okay, and the third one, well, okay, so when x is equal to 0, then we have our slope to be 0. So if you look at the slope field, here is when x is equal to 0. And it looks like we have that horizontal line, which means 3 possibly makes sense. So let's hold on to 3. Now let's check the last one. The last one, well, it looks like when x is equal to, how do we get 0 for this one? Well, we can't, because if x is equal to 0, we have an undefined slope. Undefined slope means it's a vertical line. And we don't see that on this slope field, so we're going to ignore that. So it looks like 3 is the right choice. So 3 makes sense because all of these points gives us a horizontal line, a tiny slope of a horizontal line at x equals 0. So it makes sense. Now what about the rest of it? Will they make sense? And the answer is yes, they should all make sense. Now let's test one more point. So say I want to test, let's test this slope right here. So that slope is occurring at when x is equal to 1 and y is also equal to 1. So let's check if we have, that looks like a positive slope. So that's like a positive line. And then if we have something like this, that's a negative line. So we'll call it a negative slope. But what we have is a positive slope. So let's test number 3 and see if we have a positive slope when x is equal to 1 and y is equal to 1. So I'm going to plug it in. So I have y prime is equal to 2 times x over y. Well, x is equal to 1, y is equal to 1. So we have 2. Positive slope. Check. So this makes sense. Now, if you want to be super sure that you have the right differential equation representing the given slope field, just pick another random point and see if you get that particular slope. So for instance, let's try out this one. So that point is negative 1, 2. So let's test that out. So we want to test negative 1, 2 and see if we have a negative slope. We want to see if that really happens with the same equation number 3. So if I plug those points in, I have y prime is equal to 2 times x is negative 1 over y, which is 2. So this is negative 2 over 2. Indeed, we have negative 1. So check. We have a negative slope. So makes sense. So the right equation for this slope field, it's number 3 because it makes sense with the point we tested. All right, now we can also carry the same idea of plugging in points and finding the slope and then drawing it out on the xy plane. Let's draw a slope field. for the given differential equation. So say I want to draw a slope field for dy dx is equal to, let's do something nice. Let's do 3. Okay, so the derivative is just constant, 3. Okay, hopefully we have a picture in our mind how this would look like. But let's draw it just in case we want to have a better idea. So here's our xy plane. And so I'm going to find the slope. Well, the slope is always 3 because the first derivative is 3 and first derivative represents the slope. It doesn't matter which point you're looking at, 3 meaning a positive slope. So that's the idea. So if I look at the point, so I'm going to use different color to show that. So say I'm looking at the point 1, 1. So right here, when x is 1, y is 1, what is my slope? My slope is 3, meaning it's a positive slope. So positive slope, we're going to indicate it by drawing this line. So it's more steep looking line. That's a positive slope. Now I'm just going to extend a little bit more. So let's do 2, 1. Again, slope is 3. 3, 1, slope is 3. 4, 1, slope is 3. And hopefully you got the idea. And I can also do it on the left side of the axis. 3, -2, 3, and then -3. The slope is still 3, and so on. Now let's do more points. Let's do 1, 2. So that will be another slope 3, 3, 3, 3, 3, and then we also replicate it on the left side. So you see that it's just a constant slope. So we can just replicate this over and over, and we have our slope. 3, 3. So I'm not really drawing this really nice, but I hope you got the idea what a slope field is and how it looks like. Now, if you're looking for the solution would represent an integral curve because that is one particular solution going through the slope field. So that's it for this video. I hope this idea makes sense. See you next time.